Hello, Harsh. I hope your exams are being uh, going good, performing well, and you are here to learn more about Android in general. Okay. So, welcome to the Android course. This is the last week of the course where we're gonna learn very important stuff, that is asynchronous programming using coroutines. Okay, we're gonna learn about what are coroutines, basics of it, going to some advanced level stuff. We're gonna learn how to work with Kotlin flows, coroutines flows. Okay, and in the last we're gonna build a application that summarize all the learning we have and uh, see what we have learned so far. Okay, along with that I will gonna be explaining more about Git and GitHub at the last class of this course. Okay, so cool. So uh, moving forward, I'll like to make a disclaimer that this thing that we're gonna discussing, I have put it in the course in the last as the last part of the course for few reasons. The first, that uh, understanding this needs some context of Kotlin, Android, and more things. Okay. The other part is that it's little complicated and very hard to understand at the first glance. Okay. So, in order to master this thing, or in order to understand this Kotlin coroutines, one has to invest more and more time on going through the documentation, trying different stuff, okay, and learn from the observation and from others' code. Okay, I'm still learning it, but uh, it's it's little complicated and can take some time to have a brief understanding. Okay, now for today's context, we will be learning about as obviously coroutines. Okay, we will be learning about threads. We will be learning about scopes, what are coroutine builder, and more about coroutine context. Okay, so before moving forward, let's try to do something new and see what will be the output. Okay, so let's go with the network uh, request retrofit project that we have built in our last session. Okay, where I have defined a network service which was fetching some facts from a open API. Okay, we were converting the JSON file into the Pojo class and showing it to the UI. Okay, that was called whenever the view model was initialized and we were able to showcase the data. Okay, if I let me create a new emulator, this is giving me some issue. This 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 full finish. Okay, let me put it here. Cool, our emulator is up. Let me run this app. As you see, we are able to fetch our data from server and showcase in our UI. Okay, so let's have a look what we are doing so far. If I go to my view model, You can see I'm calling my network service and calling this get fact method. Okay, and once the response has come, I'm able to populate it over the state and showing it to the UI. But the tricky part is that we are doing it inside the view model scope dot launch method. Okay, as you can see, this is a coroutine scope. Let's now spice things up. Okay, now let me, instead of suspend, let me call it simple function, which gonna give us this call type object instead of direct pojo class. Okay, so I made one change here. Okay, now I will go to my view model. Okay, this might be giving me issue. Let me do this. Okay, let me do stuff outside of my view model scope. Okay, so I'm gonna say well, request, okay, of type network service dot retrofit service dot this fact. Okay, now it's of type of call dot uh, the cat fact is now wrapped inside a call object. This call object is nothing but coming from the retrofit package, which generally gives us the more functionality to execute this API call, okay, or basically network call. So I will say request dot execute. Okay, so it will gonna execute this API for us. Okay, so if you see, synchronously send the request and return its response. Okay, so it's gonna send a request for us and give us some response. Okay, so well, response, okay, of type this. Okay, it is of type response. Okay, so if res- my bad, if response, not request, response is successful, then we gonna uh, n- populate the cake fed with some, oh my bad, we gonna populate the cake fed something like this. Okay, so if I close this thing, okay, if I run this application, what are the percentage that everything will be working fine? Are we gonna see a cake fed over the screen? Let's check it out. Okay, if I call this function, okay, you can see the app got crash, right? If I go to the log cat, go to the reason why it got crash. Okay, uh let me check for is error. See, caused by Android OS network on the main thread exception. Okay, so what is the thing being here, that in the main thread I'm making a network request which is causing me this exception. Okay, now you might be asking, what is main thread, why this exception is being happening? Okay, so if I go to just a second, my whiteboard. Okay, okay, so our Android app, okay, generally contains one special thread which is called the UI thread. Okay, which is responsible for all the uh, user input and maintaining the screen state. Okay. Now maintaining the state is mean going through all the refresh rate, handling all the user response, showing the UI elements, okay, handling the animations, basically all the things that is related to the UI. Okay. Now when I make this network call, okay, if when I make this network call on the main thread, okay, on the main thread, okay, let's assume this is a cloud. Let me create, build or draw it in the form of a blue color. Okay, here is the database. Okay, when I make a request, okay, with this new approach, I requested it, I made a request to the server, and the server send me a response. Okay, meanwhile this thing was happening, what happened, this main thread got blocked. Okay, so the key term is it got blocked. Okay, blocked for what, doing and executing this request and this response thing. Okay, in our case, let's say the blocked state took us around like 100 millisecond or 1 second. Okay, so once the main thread got blocked, the user interaction or the framework or the refresh rate got blocked, and once the things get blocked, our main thread gave us the exception that I am not able to execute the things that I was meant to do, and thrown an exception. Okay, that's why we always make a network request inside a view model scope. Okay, now what is this view model scope, we're gonna have a better understanding of it in a while. Okay, now let's assume we don't have coroutines and still we wanted to execute this task. Okay, so what I'm gonna do, I'm gonna say request dot enqueue, okay, object of type callback from the retrofit, which will be of type get fact. Okay, I'm gonna open this up and implement the interface. Okay, so in order to fix it, I have to do this. If response dot is successful, I'm gonna say get fact is equal to response dot body. Okay, and if everything anything goes wrong, I'm gonna say throwable dot message. Okay, so let me put it in a string. Okay, now let's go through this enqueue word. You can see asynchronously sending the request and notify the callback of its response, or in an error occur during the server or creating a request or processing the response. So here now the keyword is the change from synchronously to asynchronously. That's the difference. Okay, now whenever we gonna execute this call or this network call, this gonna be happening in a different thread. Okay, if I showcase you via, let me draw it better for having a better understanding. Okay, this is something important stuff that someone, an Android developer, should know. Okay, let's assume we have some UI here. Okay, something like this. Okay, something like this. Okay, okay, there is one thread. Okay, let me create it via line, let me bold it. Okay, there is some thread. Okay, uh now a new thread has been opened. a new thread has been opened, okay, where I'm executing this network request in the background asynchronously, okay, so that it doesn't disturb this main thread which was responsible for handling the UI. Okay, this doesn't get disturbed, and I'm doing my execution in a thread one, let's assume, which is created apart from this main thread, and whenever I'm getting a response, I am returning it to the main thread, and once the main thread got some data, okay, it updates the UI. Okay, so if I execute this thing, okay, you can see without even using the coroutines, we were able to fetch the data using the enqueue keyword coming from this retrofit library. Okay, the key point is that instead of making a call in the main thread, uh, a blocking call in the main thread, we are creating a new thread doing the operation, and in the form of a callback we are able to execute the data, get the result and update the state. Okay, let me know, Harsh, from till here are you able to understand what is the problem with executing things on the main thread?
Yes, sir.
Cool. Now let's assume this API, instead of returning a cat fact, do something, uh, or let's say we wanted to cache this cat fact response in our database. Okay, so because databases also needed some time to execute things, okay, we might also wanted to create a new thread here. Okay, Kotlin, we can create a new thread here, call the database instance, okay, and do operation here. Okay, as we have a callback here that we got on success and on failure, this will also have few callbacks here, okay, which gonna give us either the success or the failure response. Okay, let's say after a success you wanted to fetch more data. Okay, so in the thread you wanna open another thread and do a network request here. Okay, and again have some few callbacks with the success and the failure part. Okay, now with this you can understand the things are getting very complicated, right? पहले आपने एक रिक्वेस्ट मारी, उसके कॉल बैक में आपने दूसरी रिक्वेस्ट मारी, उसके कॉल बैक में आपने तीसरी रिक्वेस्ट मारी, राइट? सो द प्रॉब्लम विद द थ्रेड वाज दैट कि देयर वाज अ ह्यूज कॉल बैक हेल. आप कॉल बैक के अंदर कॉल बैक के अंदर कॉल बैक कर रहे हो, एंड इट वाज लीडिंग टू मैनी मैनी एरर हैंडलिंग, मतलब loose error handling, code complexity, raising of unnecessary bugs, okay, and very very hard to read the code, right? So all those problems are being handled by coroutines in a very much simpler way. Okay, let me remove, or let's put it here only. Okay, for time being I'm removing this part. Let us assume that we are getting a success response here. Okay, okay, now you can see with this code, with this code, you are just calling the method is getting executed somewhere, okay, and you're getting the output. There is no callback. And let's say if you wanted to execute something, uh, something after this, let assume this response was successful. Okay, so you can now do some other operation. Okay, let's say db operation here. Okay, let me create a suspend function just to demonstrate. Suspend fun insert data to db. Okay, let's say this took me some time. It took me some time of, let's say, 400 millisecond, and the data is been inserted. Okay, so let me print it out that the data have been inserted successfully. Okay, so if I get the response after this line, I'm gonna execute uh, database operation, right? And I'm gonna take the response here. Okay, uh, let's say the response was something like this thing, and I use this response to insert into the database. Okay, uh, cool. Like, I hope you all understand that whenever I got a response, I just executed some operations to check if it is success, and once I got the response, I inserted into the db. Now compare this stuff. Okay, let me do something like this. Okay, now compare this much of code with this much of code. Okay, where I have to comment out this thing as well, right? So using coroutines, you can do asynchronous programming in a synchronous way of writing code. Okay, मतलब synchronous और asynchronous में अंतर ये है कि if if it is synchronous, the code get executed by line 1, okay, line 2, okay, line 3, as we are dealing with from past 5 weeks. Okay, simple thing. But asynchronously, what we gonna do, we wanted to delegate some work. Let's say line 1 want take some time of, let's say, 300 millisecond. So this gonna be executed somewhere else. Okay, somewhere else, and we gonna proceed with line 2. Okay, and once this somewhere else get completed, we gonna use that result to do some operations, right? So we wanted to suspend, okay, or block some execution until we get some result. Okay, so basically we wanted to do some parallel or concurrent work, then we call it asynchronous programming. Okay, and we are doing so using coroutines, doing the asynchronous job only. This icon you see, this is a suspend function. We are doing the asynchronous call only while writing the code in a sequential way, in order. Okay, once this get executed, then we come to the different part. Once this is executed, we come to the different part. Though this looks like sequential, but the things are happening asynchronously. Okay, so the whole point of was to explain you, with threads things are possible, but it is very much complicated. Okay, and very like difficult to work with threads. Okay, so with this exercise, we understood what is the main thread in Android, how things can affect if we make some heavy operation on the main thread. We understood what are the problems with the thread. Okay, and uh, how we can solve it using the coroutines. Okay, let's move forward. Okay, and let me tell you more about threads, though we have discussed it. So threads, um how can I explain it? So for example, as I explained you about the main thread. Okay, about the main thread, it's a special thread that get assigned to a Android application by the Android operating system. Okay, every time this application is launched, a new main thread is being assigned. Okay, so thread is somewhere we execute tasks. Some processor, some RAM, some memory has been allocated for them in order to make it work. Okay, now if we create more threads, okay, which Java allow us to do so, okay, we take up some memory, okay, where we use reference from the main thread, do some execution and give some output to them. Okay, so Java or Android allow us to execute things parallelly using the threads, which consume some memory and space in order to execute things in a asynchronously way in apart from the main thread. Okay, but threads are limited. Okay, first things, threads are complicated. The second thing, it takes up lots of memory. The third thing, and it's very hard to read, handle errors and make changes upon those threads. Okay, so when I say threads are uh, m- takes up memory, let me do this little exercise which is present in the Kotlin documentation as well. Okay, so let me create a new Java Kotlin file, thread memory check. Okay, so let me create a main function. Okay, okay, now let me repeatedly create like many threads. Okay, something like this. I'm gonna create lots of threads. Okay, with a delay of let's say 500 milliseconds. Okay, oh, there should not be delay, it should be thread dot sleep for let's say uh 500 milliseconds. Okay, and I'm gonna say print thread ended. Okay, so let me execute this part. Okay, so you can see after some exception, after some executing some threads, you can see the numbers are varying from time to time because I have given this thread dot sleep uh, a large context of time. But you can see with some few numbers, let's say 3000, 5000, after let's say 5000 for some taking arbitrary number, we got some exception that out of the memory has been reached, and now my system doesn't have any much memory left to create a new thread. Okay, so indeed the threads are very expensive. Okay, and take lots of space in order to execute them, allocate them and do some operations upon them. Okay, if I do something similar, okay, in let's say I wanted to create a coroutine, don't worry, I'm gonna tell you about this run blocking stuff in a minute. But let's say I have to do something like this. I am again given something like this, and I say coroutine ended, coroutine number ended. Okay, let's try to execute this stuff. Okay, see, you can see 1 million coroutine got started, ended, okay, in a just couple of seconds without crashing the app. Okay, so you can just imagine if you're building a backend application using Kotlin Ktor, you can do so much of operations inside the new coroutines without affecting the memory, right? Whereas the same would in Java would be a nightmare. So this many of coroutines got launched, do some operation, get executed at end date without crashing the application. So you can understand, though the threads are expensive, whereas the coroutines are little lightweight and we can do lots of operations using them um, uh, without worrying about the performance and other issues. Okay, so the problems with threads are they are expensive. Okay, it takes lots of memory, thus expensive, very hard to read, maintain, and do error handling. Okay, and can be get very tedious when considered of very large application. Okay, you might be not be aware from where the things got uh, started giving problem, and it will be very hard for debugging thing as well. Okay, so to solve all those problems, we have Kotlin coroutines. Okay, um, let me know, Harsh. Till here, are you very much understood what things uh, causing the issue in the Android in our history, and why people are very much learn with love with Kotlin coroutines?
Yes, sir.
Cool. Okay. So with that being said, let's um, create a new project with experiment with coroutine and delete the other one. Okay. Now let's go to the documentation of what Kotlin coroutines are. Okay. Though we are been using it for a while, but let's go to the documentation as well. Okay. Because Kotlin is from JetBrains, let's first have a look into the JetBrains documentation. Okay, just a second. Cool. So if we go to the coroutines documentation, it says minimal low level API. Okay, to enable other libraries to utilize coroutines. Unlike many other languages with similar capabilities, async await are not keywords in Kotlin, are not even part of its standard library. Moreover, Kotlin concept of suspending functions provide a safer and less error-prone abstraction for asynchronous operation than future and promises. Okay, coroutine is a rich library for developed by JetBrains. High-level coroutines enable primitive types that include launch and async. Okay, so basically, coroutines help us to do asynchronous programming um, uh, with the suspending functions, reach APIs. Those are lightweight, help us to write code in a synchronous help us to write asynchronous code in a synchronous way, help us to have a better uh, memory management, error handling, and readability. Okay, so Kotlin coroutines was now adapted by Kotlin version in one Kotlin 1.3. Okay, and as Kotlin is the official language for building Android application, the whole coroutines concept was very much adapted in Android ecosystem, and They have created lots of util class for us to help us do the basic operation very easily. Okay, that one of them is the view model class as well. Okay, that we're gonna discuss it in a detail. Okay, so Kotlin coroutines are light threads which help us to write asynchronous operations in a synchronous way, where we suspend the function, okay, to get the output, and it is more readable, less error prone, and have few helper functions to do the basic operations for us. Okay, now let me also give more understanding of this working of coroutines. Though I cannot explain everything in a one class, but I'll just give you the basic understanding how coroutine works internally. Okay, so if I go to my whiteboard, let me. Okay, so let's have a look into the thread part. Okay, what was the problem with the thread? Okay, generally what I'm trying to explain you is the difference between blocking and suspending. Okay, so threads were usually blocking things, used to block things until and unless it was completed their execution, whereas in coroutines things are suspended. Suspended in the means, while the things was happening in the different coroutine, we are executing the different stuff. Okay, so let's assume you created a new thread. Okay, uh, so let's assume this is the main thread being running upon. Okay, this is the main thread. Okay, now you executed or you started two new threads here. Okay, this new thread here one, let's say thread 1 and thread 2. Okay, you started in the main thread, everything start from the main thread. Okay, now uh okay, let's say this, my bad, array, I'm not very comfortable with this lines things, but yeah. So let's assume this thread was executed, which was taking some time of, let's say, 500 milliseconds. Okay, similarly this thread was also getting executed. Okay, okay, and let's assume it took some uh, 300 milliseconds. Okay, and to consume this thing. Okay, let's say you have blocked your main thread for let's say, let me create it. Let's say this thing is being hold up upon for 1000 millisecond. Okay, so the problem with this approach is that once the thread is created and started executing, the whatever time it's been executing or been delayed, the thread is being the thread is been in the block state. Right, in the block state means once the thread is in the sleep, let's say where I have provided the thread sleep for 100 millisecond, this main thread will be 100 millisecond blocked. Okay, there can be no execution that can be happen here. Okay, so thus taking lots of memory and we cannot do much over here. Okay, but in the form of coroutines, let's say, okay, if I do this, okay, let us create the main thread. Okay, this main thread is the continuous process until the application get destroyed. Okay, and here I have created a coroutine 1. Okay, here I have created the coroutine 2. Okay, so once I start a coroutine, okay, once I start a coroutine, okay, okay, and there if some things come where the operation, let's say network or database operation, is being happening for, let's say, 300 millisecond. Okay, and I'm doing one more operation, I'm also doing one more operation which is taking 500 milliseconds. Okay, okay, and what the thing will happen something like that. Once this delay is been happening, this coroutine will get into the suspend state. Suspend state in the sense, once this is been suspend state, our main thread is empty to do some more operations. Okay, here you can execute more thread, more coroutines, and you are able to do more operations inside it. And once this 300 milliseconds get uh, written back, you can execute some operations here. Okay, basically here. Okay, but my point is, though the threads are blocked, where you cannot do certain operations until this block period is get over, in coroutines things are nothing like that. The the main difference in the coroutines, apart from thread, are coroutines are suspended in the sense, meanwhile the operation is happening in the different part, the main thread is active, or the other part of the coroutines is active to do some more operation in the background. Meanwhile, in Java threads, what happens, the states are in the block state. Okay, until and unless that block period is getting covered, you cannot do more operations upon that time. ओके, अगर ये 1000 मिली के लिए ब्लॉक है, तो आप 1000 मिली के लिए इस मेन थ्रेड में कुछ ऑपरेशंस नहीं कर सकते. वेयर एज लॉन्चिंग अ न्यू coroutine while the main thread is in the delay, there is always some space left where you can always execute some more coroutines inside it and have a main few more tasks inside it. Okay, so just try to understand that coroutines are suspended. Suspended matlab they are doing operation in certain different space of your uh, application memory, whereas in the blocking state it is blocked and you cannot do much until the block period is getting over. So अगर ये ब्लॉक स्टेट जब तक यहाँ पे है, मतलब मेरा मेमोरी का खपत हो रहा है, my application is taking memory, meanwhile doing nothing in return. Okay, whereas if my coroutines are taking some of space, delay भी है, and delay is in different suspending function, my main thread is always active to do some more tasks. Okay, though this thing is taking the memory. Okay, but I still have some uh, uh, space left, or basically opportunity left to do some operation while this suspending function return us with some memory. Okay, so in short, with coroutines you are saving this extra 100 millisecond for each and each operation, whereas in thread if something is blocked for 100 milliseconds, you have to wait until this 300 millisecond is been completed. Okay, and we as always learned that you can always create more threads mean the time is executing, but we are limited with the thread. Okay, we are limited with the thread, we cannot create like 1000 threads in a while and do some concurrency programming upon it. Meanwhile, in coroutine, these things is very easy and doable. Okay, so I hope you all understand the basics of blocking and suspending. Um, we're gonna have a look into that with the code execution tomorrow when we're gonna learn about concurrency in a detail. But try to understand when with dealing with threads, we are dealing with the blocking state, and when we're dealing with the coroutines, we are dealing with the suspending state. So if a thing is in the suspending state, the memory is free to do more operations. Meanwhile, in thread, we are blocked until the time get over. Okay. I hope this makes sense till now here. Okay. So moving forward. Okay. Now, if I go to application, okay, if I create a new coroutine file, okay, let's name is it coroutine builders. Okay. In my previous example, I showed you this block of code, okay, run blocking, okay, which gives us a lambda which contains of coroutine scope. Okay, now हमने इतनी रामायण तो पढ़ ली कि what is coroutine, what are the benefit and what stuff you can do with the coroutines. But जैसे हम threads को बनाते हैं using this this lambda using thread. Similarly, अगर हमें coroutines बनाना है, okay, if we wanted to build coroutine, we have some coroutines builder. Okay, primarily there are of three types: the run blocking, launch, and async. Okay, so to demonstrate it better, let me go to the code base. Okay, now let's say मैंने एक फंक्शन फन करके बनाया, अब मेरे को एक कोरोटीन बनाना है. ओके, अगर मैं लॉन्च का इस्तेमाल करूंगा, ओके, एंड इफ आई जस्ट ओपन द लॉन्च वर्ड, सिमिलरली हाउ वी हैव थ्रेड, okay, this will give me an error. The error states that a launch cannot be made unless and until a scope has been provided. Okay, now what is coroutine scope? Hold it for a 5 to 10 minutes. I'm gonna discuss it in a proper detail. But with the launch builder, it needs a scope. Okay, if I do coroutine scope dot launch, suddenly the things uh, uh, just a second, let me write it for you. Okay, now you can see, once I have a scope object with me, I can create a new coroutine using this launch builder, and I can execute my long running task here. Okay, okay, so to create a new coroutine, we can either use the scope dot launch, or we can use scope dot async to do the operation. Okay, but we gonna come to the launch and async part in a minute. But let me first give you a brief understanding of run blocking. Okay, so if you go to the launch documentation, you can see it's an extension function on a coroutine scope, which takes coroutine scope in order to execute its operation. Okay, but if I wanted to create a coroutine without using any scope, I can do so. Okay, using this run blocking method provided by Kotlin. Okay, so with this you can understand that in the lambda I am getting a block of type suspend which is of coroutine scope. Okay, so runs a new coroutine, okay, and blocks the current thread, okay, until its completion. This function should not be used from a coroutine. Okay, it is designed to bridge regular blocking code to library that are written in suspending style, so to be used in the main function and in test. ओके, तो जनरली आप अपने पूरे करियर में रन ब्लॉकिंग जब आप टेस्ट लिखोगे तभी आप इसको एग्जीक्यूट करोगे, नहीं तो जनरली वी डोंट यूज द रन ब्लॉकिंग मच. But I just wanted to demonstrate to create a new coroutine you can use the run blocking which gives us the new coroutine scope, and here I can do a suspending operation. Okay, for example, do some heavy heavy work for me. Okay, I'm gonna delay things for 500 milliseconds. I'm gonna say let me create a handy method, uh, output which gonna take string, okay, which internally gonna call println and take the string. Okay, so log thing. Okay, so log thing, and I'm gonna say uh heavy work started. Okay, I'm gonna copy it and it. Okay, now I'm gonna call this suspending function because delay is also a suspending function. I have to call it through a suspend function. Okay, so delay is is a coroutine which which suspend coroutines for the provided duration. Okay, so if I say do some heavy work for me, okay, and I'm gonna say and the program here. Okay, so if I run it, see, heavy work started, this statement got started, and after the 5 second, this thing get logged out. Okay, and only then we printed the statement, right? So with the run blocking, the things was blocked until and unless the work was completed. मतलब अगर मेरे को ये चीज प्रिंट करनी थी और या फिर मेरे को नया टास्क करना था, तो that was not possible until this heavy operation was completed. Okay, लेट्स से अब मेरे को ये चीज करनी है कि after a thing has been suspended and I wanted to do some more operation instead of run blocking. Okay, or inside run blocking, what I'm gonna do, I'm gonna create a launch. I'm gonna launch a new coroutine. Okay, okay, and if I execute it now, okay, see, once this launch was called, the code outside of it got executed. Okay, which is the end the program here. Okay, then the heavy work was started and the heavy work was ended. We got the output from here. But the good part is that even the heavy operation was happening in some other place, my thread was not blocked and I was able to do more operations, and more operations even the work was not completed. Okay, so Harsh, लेट मी नो, क्या आपको समझ में आया कि कोरोटीन हम कैसे बना सकते हैं?
Yes, sir.
आर यू एबल टू अंडरस्टैंड कि रन ब्लॉकिंग के साथ इशू क्या था?
Yes.
And are you able to understand to resolve it? We created a new coroutine using a launch builder on the scope to do some heavy operation in the background.
Yes, sir.
And while this heavy operation was happening, we were able to execute more operation in our main thread without uh, without getting blocked for, let's say, 500 millisecond.
Yes.
ये नहीं आया समझ में? Do you want me to uh, repeat it for you one more time?
No, sir. Got it, sir.
Cool, cool. Okay. Now the part is that this launch thing doesn't end up here. There is lots of stuff. Okay, आप चाहो तो अगर suspend fun, okay, do some more heavy work. Okay, I'm gonna copy this stuff, paste it here. Okay, heavy work 2 started, heavy work 2 ended. Okay, now instead of 5 second, it say, let's say it takes 7 second. Okay, now the good part with the launch is that if you wanted to execute something sequentially, one after the another, what you can do, you can do the suspend function or the heavy work. Let's wait for a couple of seconds to Hers to rejoin. Welcome back, Harsh. Let's continue. So I was saying, if you wanted to execute two suspending functions one after the another, you can do that using the launch or basically under a coroutine scope. Okay, uh, do some more heavy work for me. So you can see two operations has been happening. Okay, uh, main thread continues. Okay, okay. So one thread is taking 5 second. Sorry, one coroutine is taking 5 second. Another coroutine is taking 7 seconds. And meanwhile, this thing is happening. Our main thread is continues to do some more operations. Okay. If I run it, see, main thread continues. Once the main block driver function started, this launch was executed. Okay, though once it was executed, ये background में चालू हो गया, and the cursor started doing the operation from the 13th line and started doing its operation without blocking the main thread. Okay, so the main thread continues thing was executed. Even I have written after the launch word. Okay, heavy work started. Okay, uh, and once the heavy work was completed, then the heavy work 2 was started. Okay, and then it got ended. Okay, so to execute this two operation sequentially, okay, okay, sequentially, it took us 5 plus 7 seconds. Okay, but we don't want to do that. We want to uh, do the operations asynchronously. Okay, that uh, or uh, um, basically parallelly. Instead of doing things sequentially, I wanted to execute things parallelly. So what I'm gonna do, can anyone guess? Harsh, if I wanted to execute these things in a new thread, what can I do? Sorry, new coroutine, what can I do?
We can create a new dispatcher.
We haven't talked about dispatcher yet. अच्छा, लेट मी नो, अगर मेरे को एक coroutine बनाना है तो मैं कैसे बना सकता हूँ?
We can use launch function to scope it,
हाँ
and
हाँ.
inside it we can uh, use the function such as the delay one.
Okay, you are saying we can do something like this in order to do the thing sequentially, right?
Yes.
So this will gonna start, followed by this gonna start in the background, okay, and our main thread continues doing its job it was assigned to, okay. So if you wanted to do long running tasks sequentially, you can do inside a launch scope or a sync scope, okay, and call those functions one after another. But if you wanted to execute things parallelly, okay, what you gonna do, you gonna create two coroutines and assign the task to them inside their different scope, okay. So let's see the output. Let me run this part. See, heavy work was started, heavy 2 was started, heavy work was ended before because it took 500 milliseconds, and heavy work 2 was ended in the last because it took us 700 milliseconds. Meanwhile, our main thread was continue doing its stuff, and the program was ended only when these things was executed. So this execution got out only when this part was executed. This close bracket was executed, okay. So our thing was happening in the background, the scope was doing its stuff, and once it got executed there was nothing else to process, so our process got finished without any error. Now let's say you wanted to do some operations only after these two operations has been completed, okay. So launch is kind of a coroutine builder where you define stuff and forget how it gonna end, okay. So you just launch it and forget. So basically launch builder is something like fire and forget, okay. Whatever thing is happening inside it, we don't care, we just wanted to execute some task, okay. But this, if you go to the launch documentation, you can see the launch documentation return us a object of type job, okay. So if I do something like this, well, job 1 of type launch, okay, well, job 2 of type launch, okay. Now every job contains the data of the coroutine is been happening, the context, the scope, the activity, everything, okay. So what I meant by that, if I do job 1 and do some operation on it, you can see you can have a method called isActive, which states that whether the coroutine is being still active or not. We have a start method, we have a join method, we have a is completed method, okay. We have a is uh, we have a cancel method, okay. So what we can do, let's assume if we wanted to uh, do a job do operation only when these two jobs are getting completed. What we gonna do? We gonna do uh, list of job 1, job 2 dot join all. ओके, तो इससे हमने क्या किया, हमने इस दो ऑब्जेक्ट को एक लिस्ट में ले लिया और इन दोनों लिस्ट में मैंने जॉइन ऑल कर दिया। मतलब लेट अस प्रिंट समथिंग हियर, both the jobs were completed. Okay, now if I execute this code, see, अभी मेन थ्रेड में चीजें नहीं आई है क्योंकि मैंने जॉइन ऑल कर दिया है। जब ये दोनों टास्क कंप्लीट हो जाएगा, so then only this line number will be getting executed, which will say both the jobs were completed, and then we can execute our different work. Okay, so in order to wait until the job is getting completed, we use the join all, or basically job dot join method, in order to wait for the coroutine to get completed. So suspend the coroutine until the job is complete. Okay, so if you wanted to wait for a job to complete, we use the join keyword. Okay, now enough with the launch part. Let's discuss the async part. Okay, so this was the basic with the launch builder. Let's see the different async, different coroutine builder, that is async builder. Okay, so let's say now uh, your your suspend function now returns something. So let's say list of string. Okay, so once it is returning, we're gonna say list of, and I'm gonna say Niket, Harsh. Okay, and let's say tag 52. Okay, and we also wanted to return a list of int from here, 1 2 3 4 5. Okay, something like this, list of string. Oh my bad, list of int. Okay, now the property with the launch is, it's similar to us it's similar, sorry, the thing with the async is, it is similar to launch, but instead of giving a job type object as a return, it gives us deferred type of object. Okay, so let's have a read about its documentation. Creates a coroutine and return is future. Okay, abhi result in there, future result as a implementation of deferred. Okay, the running coroutine is cancelled when the resulting deferred is cancelled. Okay, basically instead of returning us of job object, it returns us a deferred one. Okay, deferred type object. Okay, now you might ask, what is the main objective of it? Okay, so with the async block, okay, in the launch, what was, launch is generally used in order to execute a code. Okay, execute in tasks. Okay, and do some operations on it. Okay, while maintaining different states. Okay, so with async, what we can do, whatever the, for example, you can see that this async block is returning a deferred object of type list of string, which is the return type of this operation. If I do something like print statement here, okay, now the last line of this async block is of type unit. You can see the deferred type changes. Now it is deferred type of unit, which doesn't return anything, but we don't want to do that. Okay, we wanted to return the result type that is getting from this method after having some heavy operation. Okay, now the catch is कि जब ये रन ब्लॉकिंग वाला चीज कॉल होगा, ओके, दिस async thing will get executed. Okay, you will get the output in this two uh, two methods. Okay, so अब हमें क्या करना है, हमें ये जो दो वेरिएबल है डिफर्ड टाइप के, वी वांटेड टू एक्सट्रैक्ट आउट द रिजल्ट which was getting from this builder. Okay, async builder. So what I'm gonna say, I'm gonna say print ln combined output, okay, will be of deferred one, and to get the output I'm gonna say dot await. Okay, जैसे हमने इस लॉन्च को रुकने के लिए हम वी यूज टू से जॉब डॉट join in order to wait until this launch coroutine get executed. Similarly, uh, similarly, to do things in with the async coroutine builder, we have a await functionality. Okay, तो इससे होगा क्या, जब आप जब आपका कोड एग्जीक्यूट चालू होता है, जैसे ही ये async ब्लॉक में आता है तो ये ऑपरेशन अपना बैकग्राउंड में चालू कर देता है. ओके, जैसे ही चालू कर देता है एंड इट्स रेडी टू गिव यू द रिजल्ट, एंड जैसे ही आप इसमें async डॉट अवेट कॉल करोगे तो आपको ये रिजल्ट दे देगा. बट लेट्स से ये एग्जीक्यूट होने में 5 सेकेंड लेता है, एंड समहाउ योर कोड हैव रीच्ड विद इन सम फ्यू मिली सेकेंड्स हियर. तो ये अवेट क्या करता है, जब तक आपका ये वाला टास्क कंप्लीट नहीं हो जाता, आपको या तो दो चीज मिलेगी, या तो आपको सक्सेस में रिजल्ट मिलेगा, और यू विल गेट द एक्सेप्शन दैट द टास्क वाज अनेबल टू हैपन. ओके, इन बोथ द केसेस आपको एक्सेप्शन भी इससे मिलेगा, आपको रिजल्ट भी इससे मिलेगा. बट द मेन पॉइंट इज सिमिलर टू जॉब डॉट join, we use await on async builder to await until we get the output. Okay, similarly I'm gonna say plus, and I'm gonna say defer to dot await. Okay, now this combine output will take 700 मिलीसेकेंड, बिकॉज ये जो चीज है ये 500 मिलीसेकेंड में एग्जीक्यूट होके हमको रिजल्ट दे देगी, बट इस चीज को आने में और 2 सेकेंड लगेगा. बट इस पूरी ऑपरेशन को एग्जीक्यूट करने में हमें टोटल 7 सेकेंड्स लगेंगे. ओके, so see the let's see the execution. So both the heavy work was started, we're gonna wait for 7 seconds. The heavy work ended, but still we didn't get the output. Heavy work was get it ended, but we still didn't get the output. We get the output only when the heavy work 2 was ended. Okay, and then we was able to get the combined output. Here is the list, and here is the uh, int list that we have created. And once this combined was getting finished, then only the main thread was executed. Okay, so these all are the things that we can do in coroutines. I'm pretty sure that all of you would be watching it for the first time. You all would be very, very confused. This is the natural part. In case you are not confused, I congratulate them if you have understood it. If you have slightly doubt of how things are working, I will highly encourage you to read the documentation and practice this stuff with yourself in different combinations and permutations. Okay, different combinations, and then you will understand how things work internally. Okay, cool. I hope you all have understood about the async builder. The thing is that whatever you request, you get some output of it using dot await functionality. Okay. In this example, this boy uh, uh, did operation of uh, setting up it order in Amazon, and Amazon came with the parcel. Okay. So async is something like that. You you execute a function which returns something, and to get the output you call the await functionality, which gives the deferred object, and that deferred object contains the result or exception based on the different condition. Okay, so those three, run, blocking, launch, and async builder, are the three ways of creating coroutines in Kotlin. Okay, now I'm gonna take few more minutes to give you a context of what we're gonna learn tomorrow in proper detail. Okay, so let's get into this part of our view model. Okay, let me execute this stuff. So if you remember, हम लोग जब अपना नेटवर्क रिक्वेस्ट वाला एग्जाम्पल देख रहे थे, हमने नेटवर्क रिक्वेस्ट मारी थी. ओके, एंड इट वाज इनसाइड द व्यू मॉडल स्कोप डॉट लॉन्च. ओके, नाउ because this view main view model is very much coupled with the activity main activity, and there was a case when this view model scope was in fact running on the main thread. Okay, and still executing the network request without crashing. Okay, how this thing was happening we're gonna look into tomorrow's class, but this view model scope is something very special. Okay, that we're gonna discuss in next 5 to 10 minutes. But before that, let me talk about scope. ओके, कोरूटीन्स की एक खासियत ये है कि थ्रेड्स में क्या होता था, जब वी हैव टू क्रिएट लेट्स से थ्रेड फंक्शन समथिंग. Okay, when we used to create a thread, okay, it was a plain thread which executes stuff. Okay, let's say ये thread dot sleep takes let's say 40 सेकेंड ले रहा है to execute something. Okay, this is not practically, let's assume this is taking 40 seconds. मान लो आपने ये थ्रेड को कॉल किया to do some things, और 40 सेकेंड होने से पहले if someone kills the application, there much there much there there will be possibilities कि ये thread फिर भी execute होता रहेगा in the CPU. Okay, because this doesn't know how to cancel a thread when a user have left the application or deleted or basically close the application. Okay, so कोरूटीन और कॉटलिन और जेटब्रेंट वालों ने क्या सोचा कि हम एक ऐसा डिजाइन पैटर्न बनाते हैं कि हम हमारे सारे कोरूटीन्स को एक स्कोप से बाइंड कर देंगे. Okay, and when we bind them through the scope, and whenever an activity get destroyed, okay, the scope will get triggered out, and whatever the background activity was happening, doesn't matter if it was completed, incompleted, or in progress, that will get destroyed automatically to save the memory. Okay, so that's the whole point of creating scope based asynchronous programming, so that you not only achieve structure concurrency, but you also save some memory. Okay, so to continue on the same, Google team created a view model scope. Okay, ये view model scope हमें view model class से आता है. If I go to the documentation, you can see it's an extension function on the view model scope. Okay, which is a special scope which runs all the coroutines until and unless that activity or where is or where this main view model was associated has been initialized. The scope is getting mined to the life cycle uh, of the bind activity, so that that activity get destroyed, this scope will get destroyed. Okay, and whatever things was happening inside it will get eventually deleted, and the memory will get free. Okay, memory will get free. Okay, so you don't have to explicitly do something dot if thread was completed. Okay, you don't have to do something this thing or not, and then do thread dot cancel. मतलब आपको ये मैनुअली काम कोरूटीन्स के साथ नहीं करना है अगर यू हैव डिफाइंड योर स्कोप वेरी वेल. ओके, सो coroutines in a nutshell works inside the scope. Okay, in Android we have some default special case scope where we can do our stuff blindly and don't think much upon the other edge cases. Okay, common edge cases. Okay, नाउ इफ यू गो टू दिस व्यू मॉडल स्कोप, अगर आप ये डायग्राम से देखोगे तो ये स्कोप के अंदर हमारे पास एक कॉन्टेक्स्ट होता है विच इज कॉल्ड द कोरोटीन कॉन्टेक्स्ट. ओके, इफ आई गो फर्दर, ओके, दिस कोरोटीन कॉन्टेक्स्ट कंटेन डिस्पैचर, error handler, the name of the job, and the name of that coroutine that is been running. Okay, and this dispatcher have a functionality where we have a capability to run our coroutines on a separate thread pool. Okay, जैसे अगर लॉन्ग रनिंग टास्क है तो मैं उसको मेन थ्रेड में ना करके मैं उसको डिफॉल्ट थ्रेड में करूंगा. ओके, अगर कोई नेटवर्क रिक्वेस्ट है तो उसको मैं मेन थ्रेड में ना करके आईओ थ्रेड में करूंगा. ओके, वी गोना डिस्कस अबाउट दिस डिस्पैचर in a much more detail tomorrow, but what I meant to say that everything in coroutines inbound inside the scope, and whenever that scope gets destroyed, our coroutine gets cancelled and our memory get free. Okay, so every thing you can do something like this. Okay, मतलब आप अपने लॉन्च को रूटीन्स को ओवर रिडन करके अपने खुद के डिस्पैचर दे सकते हो if you wanted to execute long running tasks in a separate coroutines. Okay, if I go into the view model, okay, you can see uh, it executes on uh, dispatcher.main, which is the main thread of type immediate, executes jobs immediately on the main UI thread. Okay, then it has a supervisor job which we're gonna discuss it in a much more context tomorrow. Okay, and uh, uh, and then we can execute our job in the main thread using the supervisor job and the main dispatcher to execute our things in the main thread. Okay, now what I meant to or what want to conclude from here, every coroutine scope that you create is of type of a job object. Okay, that job object contain coroutine context, and that coroutine context contain four properties. That is for error handling, for in the thread pool that you wanted to execute stuff, the job object to generally define the scope that you wanted to define, and the name of the coroutines for extra debugging process. Okay, now with the coroutines you can define what dispatcher you wanted to execute, or basically what thread you wanted to execute. Okay, now if somebody is getting confused here, what I meant to say, जब हमारा जो एंड्रॉयड सिस्टम है ना, ओके, इट हैव वेरियस थ्रेड पूल्स. ओके, ओके, कुछ थ्रेड होती है मेन यूआई रिलेटेड टास्क करने के लिए, कुछ थ्रेड होती है बैकग्राउंड ऑपरेशन करने के लिए, कुछ थ्रेड होती है वेरी हैवी इंटेंस ऑपरेशन करने के लिए, कुछ थ्रेड्स होती हैं आपके अनडिफाइंड वर्क जैसे क्लीनिंग द कैश, मेंटेनिंग सम अदर स्टेट्स करने के लिए. ओके, तो जब हम कोरूटीन से किसी कोरूटीन को कॉल करते हैं तो हम उसको एक्सप्लिसिटली बता सकते हैं कि भाई आपको मेन थ्रेड में एग्जीक्यूट करना है, कि आईओ थ्रेड में एग्जीक्यूट करना है, कि डिफॉल्ट लॉन्ग रनिंग टास्क में एग्जीक्यूट करना है, या अनडिफाइंड में एग्जीक्यूट करना है. वी हैव सच अ प्रॉपर कंट्रोल of running our coroutines in a definite thread pool. Okay, and in that way we can make use of our android operating system very frequent, like very effectively. And in the same way we are also taking care of memory management and the space management. Okay, so we're gonna learn more about in this uh, uh, in about those context in tomorrow session. हम लोग इसके बारे में प्रॉपरली डिटेल में पढ़ेंगे. बट व्हाट आई वांटेड टू अंडरस्टैंड, इसकी हर कोरोटीन स्कोप contains a context. Okay, and a context contains four things, that is the dispatcher, the job, the name of the coroutine, and what, एंड अ एरर हैंडलर. ओके, कि अगर कल को कुछ एरर आती है तो हम अपना एरर हैंडल भी इफेक्टिवली कर सके. ओके, कूल. So with that being said, I'm gonna end this session with this basic information only. Okay, if you have any doubt, I'm here for a couple of minutes. We're gonna discuss it, and else if we are all clear we can wrap up today's call. Tomorrow we're gonna learn more about coroutine scope and some structure concurrency error handling in a proper detail, so that I'm not sure about the practical one, but you have enough theory knowledge so that you can do practical things with your application and try out stuff. Okay, so I'm gonna wait for a couple of minutes. If we don't have any doubt, we can wrap it the session by now. Cool. I hope हर्ष आज आपने बहुत कुछ नया नया कुछ सीखा होगा. I will highly recommend to go through the documentation. अगर कुछ डाउट है तो feel free to ping me. Okay, and then we can have a broad discussion upon that. I am here to resolve your doubts or any queries. Okay, so with that being said, let's close this session today, and let's meet tomorrow at the